In this video, we're going to talk about matrix vector products. These are like a shorthand for writing linear combinations. So when do these make sense? So if A is an n by k matrix, and B is a k by 1 vector, so it's a vector that has k entries in it, then a V is defined. Okay, so in order for this matrix vector product to make sense, we need that the number of columns of A is equal to the number of rows of the vector V. What we do when we take a matrix vector product is we build a linear combination where each one of the entries of the vector become weights for the columns of the matrix. So for example, here where we have this matrix that has columns 1, 4, 2, 5, and 3, 6, when we take the matrix vector product with this vector A, B, C, the weight A goes with the vector 1, 4, and we add B times the second column, 2, 5, and we take C times the third column, 3, 6. So we're building a linear combination where these entries of the vector are weights applied to each of the columns. Okay. If we wish to, we can further combine these. We can express it as a single vector. Right? Notice that we're going to do scalar multiplication here. So we have A 4A plus 2B 5B plus 3C 6C. When we do a scalar multiplication of one of these weights by the column, each entry gets multiplied by that weight. And now we're ready to combine this into a single piece. So we're going to see A plus 2B plus 3C, 4A plus 5B plus 6C. Okay, so there are two possible sort of formats for what our answer is. We could write it in this linear combination form where we haven't yet combined it into a single vector. We've given the directions for like how to do it, or we could fully combine. Okay. All right, so in order to do a matrix vector product, the number of columns of the matrix have to match the number of rows of the vector that we're multiplying by. So if we look at this next example, where we have columns 1, 5, -3, 0, -2, 7. Notice that this guy is 3 by 2, so we have 3 rows and 2 columns. And the vector we're multiplying by is 2 by 1. The number of columns of your matrix match the number of rows of your vector. So these two numbers are equal. Okay. So let's write down what this linear combination is going to be. The entries of your vector become weights for the columns of the matrix. Okay. So we have 4 times the first column of the matrix plus -2 times the second column of the matrix. And we can leave it in this format if we wish, expressing it as a linear combination, or we can further combine this into a single, like we can express it as a single vector. To do that, we're going to scalar multiply our vectors. So each entry gets multiplied by the weight. So this is 4, 20, -12, plus 0, 4, -14. And then we're going to add along the same entries. So 4 and 0 gives us 4, 20 and 4 gives us 24, -12 and -14 gives us -26. All right, and so this is our matrix vector product.